Welcome to ClickMyProject.com. The title of the project is Pilot Reduction Techniques for Sparse Channel Estimation in Massive MIMO System. Our main motto of this project is to check the best CS algorithm for the channel estimation, that is sparse channel estimation, and which algorithm is best for the overhead reduction in OFDM system. For that, we have introduced MIMO concept, that is multiple input and multiple output system. Basically, in MIMO systems, the high current gain frequency division duplex will be implemented for downlink beamforming. In that concept, the base station will have a high complexity for training and feedback overhead. To reduce this complexity, that is to reduce the pilot signal, and the sparse channel estimation is calculated for each technique, and thus finally we get a best technique for the proposed dictionary. That is, we have formed in our system a dictionary data set. That is, we are forming an signal set with our original data that we are transmitted from the transmission system to the receiver system. We are forming a dictionary design, and for that dictionary design we are applying these techniques, and we are finding which technique is best, and we are estimating the sparse channel value. This is the flow diagram of the project. In this you can see different modules. That is, I have classified the modules, and we have implemented each stage. The first stage is to design the system. For that, we are using a massive MIMO system. We are using OFDM concept to design the system module. In OFDM system, the format is data generation and then the modulation system. That is nothing that after generating a data, we are going to prevent the data from correlation or corruption. For that, we are going to form IFFT, and then the cyclic prefix is added for the data that we have generated to avoid those interruptions. After doing this process, the transmission block is complete, and we are going to do processing. For processing, we are using comprehensive sensing method. In comprehensive sensing method, we have used two algorithms, that is convex optimization technique and greedy algorithm technique. In convex optimization, we are using basic persuade algorithm for analysis, and in greedy algorithm technique we are using four different algorithms, that is matching persuade, orthogonal matching persuade, iterative hard thresholding, and normalized hard thresholding algorithms. These five algorithms are individually applied for our system, and the channel estimation is performed. In the channel estimation, we are calculating BER, that is bit error rate, and the SNR value, and we are plotting it for the five algorithms. And then we find that OMP, that is orthogonal matching persuade, is best. For that, we are going to apply a DFT basis performance. That is, we differ the pilot interval values, and the DFT basis is also applied. For each pilot interval we are going to apply DFFT, and without DFT, how the system is performing. We are going to calculate all those things, and we are going to plot the graph. After that, the another best algorithm is NTHP, that is normalized hard thresholding persuade. In that also we are going to check with the channel taps. For each channel tap condition, we are calculating the performance, and we have plotted it. Finally, the pilot overhead is calculated for the all 5 algorithms, and we are plotting the pilot overhead. Now let me show how the project runs in Matlab 15b version. This is my source file where I have stored my codings, and this is my codings. Main.m is my main file, and the others are the sub functions that I have used. And now let me run and show how the project runs. You can see the countdown runs, that is for each comprehensive sensing method the counting will run. The first stage is LSE method. For that, now the counting gets completed, and this is for basic persuade method. After the basic persuade method, other comprehensive sensing methods are to be followed. You can see that for various comprehensive methods we have applied here, and we are comparing for each comprehensive method by estimating the channel values, and we can see the difference in the plotting graph. Now for orthogonal matching persuade, it is running. For orthogonal matching persuade, as per our concept, we are running the coding for 4 times. For each condition we are running the same thing. You can see the countdown will repeat for 4 times. You can see that the countdown is again running from the 1. This countdown is simply to show how far the coding is working. For that only this counting, it is not much more important. To recognize what process we are running, that for that only the countdown is running, nothing other than that. You can see for whenever the point 1 or 1 starts from the first, then you can understand that the new comprehensive algorithm is running. Like orthogonal matching persuade, for normalized iterative hard thresholding concept also, we are doing it for 4 times. As for each channel tap value we are comparing, we have 4 conditions for channel tapping. For all the 4 conditions we are running the coding, and we are checking it with the plotting. Now the project runs for last algorithm, that is IHT. After completing this process, we will have the comparison plotting graphs. Now all the comprehensive algorithms have been completed, and the final evaluation stage is performing now. These are the output graphs. We will have 5 output graphs. This is for each algorithm. We have calculated bit error rate and the SNR, and we have plotted it. This is the comparison, and you can see that the basic pursuit is not much more effective, and the other algorithms are more and more effective. And in this graph is for OMP process. Without performing DFT, we have deferred the pilot interval alone, and we have calculated two plottings, and with DFT and pilot interval how the process works. This is the plotting graph for that. And then this graph is for NHTP, and in NHTP we have deferred the channel tap values. You can see that the channel tap values for each plotting is 4, 8, 12 and 20. For all the 4 values we have performed the process, and then this is transmitting time graph for all the process. And this final graph is for IHTP and the pilot overhead content. Thank you for watching this video.